A wide range of flowering plants often rely on insects to be pollinators in order for reproduction to occur. Some plants can even leave small nutritional rewards in attempts to encourage the insect to be a successful pollinator. Raising the intrafloral temperature is not only beneficial on the flower, but it also proves to be beneficial for the pollinator, providing energy benefits. As bees are one of the most prolific pollinators of flowering plants, it is important to understand how both temperature and nutrition paired together play an active role on the enticement of pollination. The bees at study were the Australian native stingless bee, the Trigona carbonia. The aim of the studies conducted was to test whether or not the bees preferred a higher nectar temperature opposed to that of a cooler one. Tests were conducted in the Monash University between November 2008 and February 2009 under controlled laboratory environments of 3 by 5 meters. The laboratory was under a controlled temperature and was set between 4 and 40 degrees Celsius with the humidity set to 30%. To accurately measure the activity of the Trigona carbonia in the laboratory environment was roughly equivalent to that of its natural conditions. The number of individual bees leaving the nesting box and entering into the flight arena were counted. For each ambient temperature, data was collected over 20 5-minute intervals, taken at random between the times of 1100 hours and 1400 hours, which is the bee's peak activity time. In relation to the previous study, thermal imaging of bees in the warmer conditions were also recorded to accurately ensure a correct link was being formed between preferences of nectar temperature. Individual bees filmed immediately were engaging in one of 4 activities. These activities were resting for at least 5 minutes, flying, drinking sucrose from a feeder that is at ambient temperature, drinking from a feeder that is above ambient temperature. The 4 activities undertaken by the bees are recorded as having temperatures of 23 degrees Celsius, which is on the top, 30 degrees, which is in the middle, and 34 degrees Celsius, which is on the bottom. To ensure that the readings were accurate, a probe was put against a thermal camera and then checked against a mercury thermometer to ensure temperatures did not vary. The body temperature of bees varied to which activity they participated in at the time. Whilst resting or drinking from the ambient temperature feeder, the bees were recorded to have the lower temperatures, although while flying and drinking from the above ambient temperature feeder, the temperatures recorded by the bees were substantially higher, thus drawing the conclusion that the above ambient temperature feeders were more beneficial to bees' productivity as previously stated. Having a body temperature of 34 degrees Celsius is much higher than a bee's temperature at flying. This suggests that the lower ambient temperatures, warm nectar is preferred to preserve body temperatures during flight rather than allowing cooling down that would occur during resting and pollination. This information is therefore consistent with the theory that warmer nectar offers more benefit to pollinators.